So what we're going to do is we're going to go over one simple Punnett square, and that way you can see exactly how to complete this. And then we are going to look at more complex Punnett squares, which is more similar to what you have of your homework. So whenever you're looking at this, you first have to go through, identify your actual alleles with their trait, and then you can identify your parental genotypes. So we're using example 3 with rabbits. That was used in the notes. That way, if you need to hear this a second time, you can look at this one and follow along with me in your notes. So it says that white fur is dominant and brown fur is recessive. So the first thing you have to do is identify what is actually dominant and what is actually recessive. Then you make yourself a key. So instead of just going through and making some random key, you make it according to what they give you. So if they give you white, and it's dominant, you assign it a capital W. And you use the first letter of the dominant trait. And then the second one we have is brown. And so since it is actually recessive, it gets a lowercase w. Now remember, whenever you're doing this and you have different letters that look similar, like a capital W and a lowercase w, you need to over-exaggerate and under-exaggerate like what we were talking about in class, otherwise you won't be able to tell them apart. So now that we have this is the main part. You go through and you figure out who your parents are. So it says that you cross a heterozygous white with a heterozygous white. These are the two parents. Now remember, heterozygous means different. Hetero is two different ones. So if this parent is heterozygous, then that means its genotype is going to be one big one and then one little one, because it's two different. So that's parent 1. Parent 2 is also heterozygous white. So then you put parent 2 on the side, and again, since it is hetero, that means you have one of each. One capital, one lowercase. Now, you just fill in the blanks. So this one gets drug down, this one gets drug over to give you a genotype of big W, big W, big W, little w, big W from up here, little w, and then over in the bottom right hand corner you have little w, little w. So now for the probability. I told you to use a standard procedure where you take probability and you make a chart. You list all of your genotypes and then all of your phenotypes. So the first genotype we have is big W, big W. So I'm going to put big W, big W. Now since that's a genotype that we have, we actually, if you refer back over here, we only have one big W, big W. So we're going to put a 1 here. And then now we're done with this box. Then the next one we have is big W, little w. And we actually have 2. We have 1, 2. So we have 2 of those. And then the very final genotype that we have, and so we're done with these now. Then the very final genotype we have is 2 little bitty w's down here. And we only have 1 of them. So we're going to put a 1. Now, remember, this is out of fourths. So whenever you're looking at how to complete this, since it's out of fourths, every fourth is 25%. If you have 1/4, like right here, it's going to be 25%, whatever this represents. So if it's 2 capital W's, and capital W represents white, then it's going to be 25% white. Then this one over here is 2 out of 4. So that is 50%. Now if you look at this one, I'm going to come over here. It's a big W and a little w. Whenever you're looking at this, that means you have one dominant and one recessive trait. It only takes that one dominant to show dominance. And the dominant trait is white. So again, this one will be 50% white. And then the finally little one down here is little w, little w. This is completely recessive, so then you refer back to your key. Little w means brown, so this one is 25% brown. Now, we have two percentages here. We have 25% white and 50% white, but for their phenotype, the physical trait, it's both white. So we can actually condense this into a total of 75% white and 25% brown. Now we're going to look at one of these that's also on their notes. They may or may not have gotten to this, but I want to go ahead and explain it. That way you guys have this as an example, and then we'll go to a homework sheet that's similar to what you have, but not the exact same one. So number 1 says, in purple people eaters, one horn is dominant and no horns is recessive. Remember, you always identify dominant, recessive, and then figure out your parents. So one horn is dominant, no horns is recessive. So since we're talking about horns, I'm going to use a capital H for one horn. So I'm going to put 1 is a capital H. None is a lowercase h. Draw a Punnett square showing the cross of a purple people eater. So anytime you say showing the crosses, that's where they're about to tell you about the parents. So it says, draw a Punnett square showing the cross of a purple people eater that is hybrid for horns and a purple people eater that does not have horns. So the word hybrid, the hybrid is a mix, which is the same thing as saying heterozygous. So you have one parent who is going to be hybrid, which is heterozygous, so that it will be big H, little h, and then you're going to have one parent that does not have horns at all. And so if you look back at your chart right here, not having horns at all is recessive, and the only way that you can show a recessive trait is to be fully recessive. Then you just fill in your Punnett square, so that's going to be big H, little h, little h, little h, big H, little h, little h, little h. Okay, so our Punnett square is complete. Now we have to figure out what we need to do with our Punnett square. It says to summarize the genotypes and phenotypes of the possible offspring. So this is where my chart comes into play again. Genotypes, phenotypes. Genotypes, for those who need this refresher, this is your genes. Phenotype is physical. So we go square by square again. The first one we have is big H, little h. So I'm going to write that over here. Big H, little h. How many of them do I have? I have 1 right here, 2. So I'm going to put a 2 here. The next one that you have is little h, and you have 1, 2 of those as well, so 2. Our phenotypes for the genotypes is going to work the same way. This one has at least one capital H. So if you go back up and figure out what your capital H actually represented, it represented one horn. So 2 out of 4 is 50% with 1 horn. Then you have 2 little BDHs here. This means no horns. And since there's no capital letter at all right here, it's going to show fully recessive traits, which means it will be, if it's 2 out of 4 total, 50% of no horns. That way you can see exactly what's going on with these Punnett squares. Now, not every time will you be asked to do just the general genotypes and phenotypes. You may be asked particular specific questions, and that's where you need to be able to complete this type of a Punnett square and in this format to be able to determine that if these two crossed, say if this parent and this parent crossed, there's a 50% chance their offspring will have horns. And there's a 50% chance their offspring will not have horns. So you need to be able to determine the chances and things like that. So like this one, in number 2, it says in seals, the gene for the length of the whiskers has 2 alleles. So anytime it says it has 2 alleles, that means it is an actual gene, just 2 letters put together. The dominant allele, capital W, codes for long whiskers. Little w codes for short whiskers. Okay, so we have our key here. We have big W is long, little w is short. What percentage of offspring would be expected to have short whiskers from the cross of, so 2 long whiskered seals? One that is homozygous dominant, so if it's homozygous, it's the same. And if it's homozygous dominant, that means they're both going to be dominant. So I'm going to go ahead and put him over here. Homozygous dominant, big W, big W. And one that is heterozygous. If it's heterozygous, it's one of each. Big W, little w. So then you fill in your Punnett square. Big W, big W, big W, big W, big W, little w, big W, little w. Now, what percentage of the offspring would be expected to have short whiskers? So we're looking for the chances of short whiskers. So now let's do our cross. We have genotypes and phenotypes. Let's list our genotypes. The first one we come by is big W, big W, big W. Sorry. So big W, big W. We have 2 of them. So I'm going to put a 2 here. Big W, little w is the next one. And I have 2 of them. Now let's figure out our phenotypes. It only takes 1 capital letter to show dominance, and so I have at least 1 here. So this is going to be 50% long. And over here I have at least 1 capital, so this one, 2 out of 4, again will be 50% long. So now from looking at all of this, if you expect someone to have fully short whiskers, their genotype would need to be little w, little w. That's not what we see at all possible in our Punnett square. So the answer to the question would be an overall resounding 0% of this cross would actually have short whiskers. Now, I want us to look at some or an example problem, an example page. So I'm going to bring up one that's similar to what you have for homework. Which this one? This one's kind of similar. Okay, so down here, we're going to look at SpongeBob. Okay, so my question says SpongeBob SquarePants recently met Sponge Susie Roundpants at a dance. SpongeBob is heterozygous for his shape, but Sponge Susie is round. Create a Punnett square to show the possibilities that would result if SpongeBob and Sponge Susie had children. Hint, read question number 2. So let's go back up. Question number 2, determine the genotype. So let's see. SpongeBob is square, Sponge Susie is round. Square is dominant to round. So SpongeBob is square, and he is heterozygous. That means he is going to have, he's heterozygous. That means his genotype will be big S, little s, because it's two different. So big S. And then make sure you have this other S really tiny over here. That way you can see the difference. Sponge Susie is round, so if square is dominant, and that means round is recessive, only way that she's round is that she is fully recessive, so she gets two little bitty S's over here. List the possible genotypes and phenotypes of their children. So let's fill in our Punnett square and see what we've got. Big S, little s. Big S, little s. Little s, little s, little s, little s. So the possible genotypes is there, you could have 2 big S, little s, 2 little s, little s, and then phenotypes would be 50% round and square. So what are the chances of a child with a square shape? So if you look back at your Punnett square shapes are only going to be this one and this one because square is dominant, so that's a capital S. So they have a chance of 2 out of 4, which is what we had at 50. Chances of a round shape, which is fully recessive. Again, fully recessive. 2 out of 4, which is your 50%. So let's try one that's a little bit harder that asks for specific genotypes and phenotypes and those things. So here's a good one. Mr. Krabs and his wife recently had little crabbing, but it has not been a happy occasion for them. Mrs. Krabs has been upset since she first saw her new baby who had short eyeballs. Okay. She claims that the hospital made a mistake and mixed up her baby with someone else's baby. Mr. Krabs is homozygous for his tall eyeballs, while his wife is heterozygous for her tall eyeballs. Some members of her family have short, which is the recessive trait. So up here, tall, if short is recessive, that means tall is dominant. And then short will be a lowercase t. Or you can use I for eyeball, however you want to do this. I'm using T. Some members of her family have short eyeballs, which is the recessive trait. Create a Punnett square using capital T for the dominant gene and lowercase t for the recessive. So, go back. It says Mr. Krabs is homozygous for tall. So if it's homozygous, it's the same. If it's tall, it's a capital T. So, big T, big T. His wife is heterozygous, which is two different, so it's going to be one of each. So then you fill in your Punnett square. You got two T's here. You got two T's here. Big T, little t. Big T, little t. List the possible geno and phenotypes for the children that they could possibly have. So we have, if you look right here, we have two, big T, and we have two of them. 1, 2. So 2, big T, big T. You have big T, little t, and you have two of them as well. So that's 2. Now if you notice, in each of these situations you have at least one capital T. So each one of these situations is going to show the dominant trait, which means their offspring should all be 100% tall eyes. So then you have the question, did the hospital make a mistake? Yes. Because their child has short eyeballs, and there is a 0% chance of these genotypes giving you an offspring with this gene. They will only produce the phenotype of tall. They cannot produce a homozygous recessive baby. So I hope this helps. If you have any more questions, just let me know. I am more than willing to help you. This will show you how to do some of the questions that you guys had on your homework. Remember, just go through, identify the alleles. This is an allele, the single letter. Identify what it stands for. Figure out your parents. Complete the Punnett square. Figure out genotypes and phenotypes. And then answer the question.